I'm so very happy that you've reached this epic moment in the course and that you're hanging in there. This is where things have gotten really crucial, and we're learning some of the most important things about building LLMs. And I'm just very grateful that you've been staying along and hopefully enjoying it as much as I am. Yeah, the best is yet to come. So. For today, it's going to be few slides. It's going to be all action. You're going to be looking at the actual run happening in weights and biases, and I'll be showing you the sorts of things to look for and how we can use weights and biases to get some intelligence about what's happening. I'm going to show you the Hugging Face Hub with models in it, and you get a sense of what's going on. There's also one thing that's been on my mind that I mentioned last time, that I don't want to be flippant about the importance of keeping costs low. The idea of this class is not to build up a big bill for you from Google, who will happily take your money for running their boxes. I have a lot of fun running this training. It's running the training process. It's perfectly achievable to do that and get good results with spending a matter of cents. And I did want to take just a quick moment to talk about that because it's very important, and I don't want to lead you down the wrong path thinking you have to spend lots of money to get good results and to learn particularly, which is the main objective here. And so, in fact, we're going to start with that. And I want to take you straight over to Jupyter Lab, not to Google Colab, but Jupyter Lab, where I'm going to show you something to illustrate my point and to help set you up should you wish to be training at a lower cost. So I'm taking a moment now to explain that the training costs of optimizing a model for this course can be very slim indeed. It can be a matter of a couple of cents, and you don't need to go berserk and be doing what I'm doing and using A100 boxes and big training runs. And just to clarify that, so first of all, as I explained last time, you can run on a box like a T4, which is very cheap. You can have a batch size, the largest that will fit on that box, it's probably 1 or 2, and then run training that way. But if you do that actually with the training data set that we've been working with, it will take a long time, which is still going to add up to a bit because we've just got lots of data. And I wanted to explain that actually it's not necessary to be training against this monstrous data set. I do that because I want to show you some really quite strong results, but you'll get great results with a much smaller data set too. One thing I would suggest, though, you can just take the data set of 400,000 data points and just select from it the first 20,000 and run with that sub data set, and that would be totally fine. It's probably better if you're going to do that if instead you focus in on one particular type of product that's being priced, because that way the model will have opportunity to learn all about that product. For example, you could choose appliances, which was one of the data sets that we pulled down from the Hugging Face Hub at the very beginning. And instead of bringing down all of these data sets, you could simply bring down appliances only. And I've set up a Jupyter notebook, not on Colab, just a local notebook. It's in week 6, where the other days were for week 6. We actually built this data set, the full one, on day 2. So this is a copy of day 2, but it's just made much simpler and more narrow to only look at appliances. And because it's such a small data set, it will run super fast. We connect to the environment. This is will be a throwback to the past. It's complaining because I've already logged into Hugging Face and I tried to log in a second time, but ignore that. Now we're just going to take the data set names, and I've commented everything out except for appliances, which you may remember was one of the really small data sets. Hugging Face is really upset with me for running it multiple times, but there we go. Off it runs. The total time it takes to load in this data set is about 0.2 of a minute, if I remember right, 0.3 of a minute even. And when we do that, we've got 28,000 items. So it's a lot smaller than the 400,000 data set we've been working with, but it's a perfectly respectable number for QLoRA, and it has the benefit of being focused on appliances. So it's a narrower data set. Yeah, You can follow the rest of these charts. I've taken out the charts that don't matter, like the comparison of different data types. This is the price. The average it's a smaller average, but still you get all the way up to 999, and that is the curve. And then to curate this, there's nothing really to it. We're going to take the entire data set. This is that same chart now for our smaller data set, showing that there isn't a material correlation there. And we can just quickly confirm that the same thing applies to the tokens as we checked before. And then finally, when we divide that into a training and test data set, we'll take the 25,000 items for training and then 2,000 for test. And everything else will work just great here. You'll see the training prompt, the test prompt. We can plot the distribution of prices in the test set. There we go. We've got a perfectly decent spread. And then finally, we can create the prompts from this, just as we did before, and then upload this to Hugging Face, potentially give it a different name, like I've called it light data here, and also make the 2 pickle files. Yeah, then you can use that in your training instead. It will build a model based on smaller populations of data that will be focused on predicting the prices of just home appliances rather than all the different types. This will work great. I think it'll be a good exercise for you to have to make those small changes in various places in the code to focus in on this smaller data set. And I have run this myself, and I can confirm that whatever result we're going to discover from the main run we're doing with the 400,000, the same will apply in this case in terms of how it stacks up compared to other models. Not as much as will be the case with the bigger data set, but without giving the game away, that the important things will happen even if you're focused on appliances. And obviously, when you're dealing with the data set of 25,000, you can get through it very quickly indeed. But should you do that, and should you then get the bug like I have and want to then go and do a bigger run, then of course you can add in more types and you can spend a few dollars and then be doing it for the full data set. Anyway, I thought I'd go through that. This may be good revision for people on how we curated the data. And should you wish a smaller data set, it tells you how to do it. All right, in the next video, we go to weights and biases, and we look at how the big run with the 400,000 is coming along, and we poke around weights and biases to see what more can be done there. See you there. So here we are now back in the collab in the same one that we kicked off in the previous day. It's now somewhat misleadingly named week 7, day 3, because we are of course on week 7, day 4. But I daren't touch it for fear that I stop it in some way. You can see that the GPU RAM continues in its nail-bitingly close to the ceiling level of 38.2 out of the 40 gigabytes, but it's luckily not changing, not going up. And you'll see here, this is the printout of each of the different batch steps as they happen. We're now on batch step 4,350. And if we zoom all the way up, which again, I'm doing everything very delicately so I don't accidentally stop the batch in some way, you can see that we're only a little tiny way into this strip that represents all 3 epochs. So one about there, perhaps, is a complete run through all of the data. And you can see we're at batch step, I can't say the number because it's ticking too fast, but 4410. There we go. Out of this very round number that you see here of 100,000. And you might wonder why it's quite so round. And it's just something of a coincidence. Remember, we have 400,000 data points, but they're in batches of 16 or in any one step. So if I take my calculator here for this trivial maths, take 400,000 and I divide that by 16, and then I multiply that by the number of epochs. I thought we had 3 epochs, but it looks like we have 4 epochs. I left it at 4 epochs. Yeah, if you then multiply that by 4 for 4 epochs, you do end up with, just to You have evidence of that. There's the camera. 100,000, and it's that is the 100,000 here. It's not just a wild randomly round number. It is in fact exactly the number of batch steps involved in 400,000 data points grouped into batches of 16, done 4 times over. So off it ticks, and you can see just from looking at these numbers that we started with quite high training loss, and that number has come down quite significantly. But it's sort of hard to tell from here exactly what's going on, because the numbers bounce around up and down, and it's hard to get a sense of the trend. If only there were a tool that would allow us to visualize the progress of the batch in a way that could allow us to compare between different runs and the like. Of course, there is such a tool, and it's Weights and Biases, and it's sitting right here. And this is the result of our run. This is it happening right now. This is showing us what's going on. So this training loss here is the real thing. This is what we really want to look at. Let me just edit this panel so we get to see it a bit more. Now, the y-axis here goes all the way down to 0, where 0 would be zero loss, which would mean perfection. It would mean that the model is always predicting with 100% confidence the next token, and that next token that it predicts with 100% confidence is the right next token. So that is an unlikely place to get. In fact, one would be suspicious if you got much below 1.5. Typically, this is a bit of a rule of thumb thing, but generally speaking, that would be like a great loss to have, and below that might cause you pause for thought about whether overfitting is going on. Let me change these axes and make the minimum of the y-axis 1, so that, well, we can do even better. We can make it like 1.4 or something, so that we can really see what's going on here. And it's a bumpy line, but it is pretty clear, even at this early stage, that is a bumpy line that has an improving trend. Unlike when we saw this with GPT and the fine-tuning, when it seemed to be bouncing up and down, but not really showing a trend. I think you can see that this looks like it's improving. We can also apply the smoothing thing and see how that looks. I mean, that's clearly, isn't it? That is a line that is improving if we apply the smoothing factor. Now, why do these bump up and down? I mean, it depends. Really, it's remember, each of these points represents 16 data points, 16 prompts with a thing for it to predict at the end of it, shoved into one. And it's a random, it's been jumbled up, so it's a random set of the 16. And so who knows which products are shoved into the 16? There could be some really expensive products that it's making a wild guess at and getting completely wrong. So there's plenty of noise because there's a different makeup of each of these different batch steps. And it's good to have a bit of noise, because you want to be shaking things up a bit and getting the model to be being bounced around. In a sense, again, I'm being very hand wavy, but because you're trying to not get stuck in a local minimum, but be trying out different possibilities with the idea that the model will improve and find a big global minimum, a big valley, as it tries to find gradients and improve its ability to predict the next token. It's just moved on a little bit. And again, it's very clear that there is visually some improvement happening here. So what else can we see? So this is the learning rate. This is that key hyperparameter about how much of a step it should take. And I told you we'd chosen a cosine learning rate. And you might be a bit surprised to see something which doesn't look very cosine-y at all and doesn't look the way I described it. And what you're seeing here is that thing called warm-up, which is the fact that it doesn't start up at the 0.0001 at the highest number. It starts at 0 and builds up to that point, because you can see the beginning of the batch is quite a dramatic movement from being way off to being in a better position. And you don't want the learning rate to be too high then, or it might overshoot in all sorts of ways. So that's the theory behind this warm-up part of the process. And you can see it really coming to be here. And you might wonder why this isn't really showing much in the way of a cosine kind of shape. And that's because it's so early in the training still. We're still at the very top of this cosine. It's about to start curving down, and it's doing that very slowly. Yeah, there's also some fun charts here that show us what's going on the GPU. Some of these are more meaningful than others. There's some here, the power usage and the time spent accessing memory is good. I want to see the CPU utilization. Where is that? I mean, the GPU, even the CPU utilization. The GPU utilization would be the perhaps one of the most important, to make sure that the time that the GPU is hard at work, it's not like it's shepherding memory in and out, and that's what's taking the time. You want to know that the GPU is being utilized, and that's a great sign that we are hammering our powerful A100 box and making the most out of it. And if you're using a different box, then and you've got some different hyperparameters, then come and check out the GPU utilization. Make sure it's doing well. Make sure it's nice and hot, and that you're getting good use out of your GPU. Otherwise, you might want to tweak some of the hyperparameters to see if you can't get more juice out of it, so that it's your training process is more efficient. Okay, so what I'm going to do now is do a bit of a cheat. I'm going to do what they do in those cooking classes, or like cooking videos, when they put it in the oven and they say, and now here's one that I did earlier. They take it out of the oven and it's the thing that they put in. You know, it's like, oh, that's just cheating. But I have done that, in that I did kick this off a while back, and it ran with the same hyperparameters, so the same thing. And it's this pink one right here, and this I should have explained, I'm so sorry. This here is showing the 4 runs that have happened under this project, the project which is called Pricer. So up at the top here, this navigation, it has the Pricer project, and down here are the 4 runs. And this run here was when I ran either 3 or 4 epochs of this model with this same data set, and with the with everything else the same. And so if I show you that, we'll see what happened as a result of that. And here we go. So this is the meaty one. So let's bring this up, and we are going to have to change the scale. We're going to have to come down. There we go. Now you can see everything if I leave it at 1. Okay, so a few things to point out. So first of all, you're seeing a purple. Let me click. I think if I do this one here, it's going to bring it up. There we go. So you can see here a blue and a purple line. The blue is just here, and the purple is here. The blue is the current run that is running right now. Over on this tab, it's this guy that we are running right at the moment. The purple is the one that I kicked off a while ago. Of course, it has the date in there about 10 days ago. And you can see that the blue is tracking extremely closely to the purple, which is further evidence that I'm not cheating here. It is the case that blue will continue to follow the same trajectory as the purple. The purple has just had its course. Now, what you'll see is that the trend indeed improves and improves and improves, which is good-ish. So first of all, you'll see that it improves, and then it takes a little dive, and then it improves, and then it takes a little dive again, and improves, and it takes an even bigger dive. And so you might be wondering, what are these dives? Well, these dives are the end of each of the epochs. So this is an entire epoch. That's epoch 1, that's epoch 2, that's epoch 3, and this is epoch 4. And unfortunately, it crashed, or Google reset the instance halfway through epoch 4, so we didn't get to see how epoch 4 ended. But as you'll see, that proves to be unimportant. So why is there this sudden drop at the end of each epoch? Well, that's a very good question. It's extremely important. It's because what's starting to happen is a little bit of overfitting. What's happening here is that the model is seeing some of the same data that it already saw in the first epoch. Now, sure, it's modeled up differently. It's seeing them in batch batches that are different sets of 16 than the ones it got here, Hugging Face takes care of that for you. The SFT trainer automatically reshuffles the batches each time. But nonetheless, the model has had the benefit of seeing this data before, and it can take advantage of that. It's learned something despite the dropout, despite some other things we've done to try and regularize. It still has a leg up on the fact that it's seen this exact data before. But luckily, there's only a small step down there, so we don't need to be too concerned that there's overfitting happening. But then it gets worse here, and it gets significantly worse here. And so this is a big sign of overfitting. And now, if I had been doing what I told you is a best practice, and I should have been doing, which was running validation runs at the same time, the chances, first of all, they wouldn't have taken these little jump down, but secondly, it would have probably started to go up at this point because we're overfitting. And indeed, I have savings of the batch at this point. And sure enough, it was saved up to the Hugging Face Hub every 5,000 steps, so I could test it. And sure enough, the results do get worse past the third epoch. So there was no point in going more than 3 epochs. So it didn't matter that Google pulled the plug on my instance at this point because this data was actually no longer useful. The model was already doing poorly. And again, this is a great example of where you can regularly upload to the hub, and then you can go back at each of these checkpoints and run your test over them, and you can pick the model that performs the best. And that's a very powerful technique for so that you don't have to guess how many epochs to run. You just run too many and then select the one that has the best results out of your training data, out of sample, when you're trying something new. So I think it's a really good illustration of how this works and of the effect of overfitting and the effect of different epochs. But what we know for sure is that during that first epoch, say, because it was always seeing new data, all of this slope downwards is all representing good improvement. And I can tell you that the results at the end of here were also distinctly better than here. So this was also showing some improvement. But around here, it started to get a little bit more dodgy. And maybe coincidentally, that is at around the 1.5 level. And I mentioned before, there was that rule of thumb that less than 1.5 maybe is a time to be raising an eyebrow and looking again at your results. So I will pause at this moment. And when we return, we'll talk a little bit more about a couple of other things. So this is where I left you, looking at this satisfying chart on training loss and seeing the training loss coming down. Could stare at this all day, but we will move on to other charts. Let's go back to this diagram again. I wanted to point out this one that you may have already seen. This is the learning rate. Let's blow this up. So this is showing you exactly what I was trying to describe earlier, but as I told you it would, it looks much more clear when you're looking at it in weights and biases. So this is showing how the learning rate changed over time from the beginning through to the end of the almost four, didn't quite get to the end of the 4th epoch when I ran the model before. And what you can see is that the learning rate started at 0. It then went up because of the warm-up to this point here. And then you can see that it gradually comes down in this very nice, smooth way, slowly to start with, and then a lot more. And then at the end, it tails off. And the idea is it actually gets to exactly 0 when your 4 epochs are up. But I didn't make it to the end of the 4th epoch. And obviously, if you choose to run for 1 epoch, then you get this whole chart just for the 1 epoch. It just takes the number of epochs that you set and it smoothens the learning rate over that number of epochs. So it hopefully illustrates exactly the point. And you can see that our blue line representing the current batch is right up at the top of this. And it looked flat to us only because we're at the very, very top. But in due course, it is going to come down smoothly, just as its predecessor did. So then another thing I wanted to mention is that when we were looking at the different runs just here, you can see you can use this eye icon here to decide what you're going to be looking at. And I didn't put an eye on this one here in between. Now what this is that after this batch was brutally kicked off its instance by Google, I was annoyed and decided I wanted to try and continue where it left off and run another couple of epochs. Even though the results got worse, I wanted to see what happened. I wanted to take it to an extreme, and I wanted to make sure it wasn't just an anomaly that the fourth epoch the results got worse. Maybe the fifth epoch they would suddenly be a lot better. So I at least wanted to see it play out a bit. And so I'm going to now show that for you. Now it's going to be a bit confusing because I started it again. It's not going to continue off to the right here. It's going to begin over on the left. So you just have to bear in mind that it's going to see it as if it was the first training step. But in fact, what I'm going to show you belongs over to the right of this purple line. Let's see now this thing. And there it is. So let me blow this up. So hopefully it's clear to you that there should really be over here. We should be able to take that and pull it over to the right, because this is what happened when I resumed that SFT trainer from where it left off down here. And what you can see is this is then basically a fifth, another full epoch, representing that we never completed the fourth one, but this is like doing a whole nother epoch. And then this would be like the whole of the sixth epoch. And what you can see, again, another of these falls between the when it started the sixth epoch. And at this point, definitely in a very suspicious territory, the loss looking too low. And sure enough, when I took these versions of the model and tried to run tests against them, they were all poorer in performance than the model that I took from a cutoff about here. So it was a test worth doing. I needed to satisfy myself that it wasn't just bad luck back here, but that it really was overfitting and that I wasn't getting useful results anymore. And that did prove to be the case. So it was a good test to do. And you can benefit from this because you can know if you have decided to do the full Monty and run with this big version of the model, then once you've done you might as well not go beyond 3 epochs. There is no use for that in my experience, unless you've tried changing hyperparameters and you've discovered something different. So then the final thing I'll show you, you can play around with many of the other charts in weights and biases. There's lots to explore. You can look at the gradients themselves, and that is quite a rabbit hole. And you'd have to do a little bit of digging and research to understand what you're looking at and how to learn things from it. And ideally, the main things that you want to be looking for is making sure that you never get into a situation where your gradients are becoming 0, which means that you're not learning anymore. If your gradients are 0, then your model is no longer learning and there's no use to be continuing the learning process. So you want to watch out for gradients being 0, and you also want to watch out for gradients blowing up and being too high, because that means that your model is going to be bouncing around too much. Unless your learning rate is really tiny, your model is going to be not learning in a productive way. So those are some of the things to look for when you're looking at gradients in weights and biases. But the last thing I wanted to show you was going to Hugging Face. And just show you, if you remember this model here, which is the version of the Pricer model that I ran for all of these epochs. You see the name of the run is the name that I constructed based off the date and time. And it ends in 39, the number of seconds. Just keep that in your mind. When we turn to Hugging Face, you go to the avatar menu and to your own name. You will then see your spaces, if you have any, your models, and your data sets. You can see I have 1 or 2. And when it comes to Pricer, I've run this once or twice. And each of these represent the different repos that represent one of the different Pricer runs. And I like to keep them, each of these runs as a separate repo so that I can have all the different epochs and everything within this one repo. So what this 139, I think, is the one that was the big guy with the 3.5 epochs. So if we click into this, it comes up with the model page. And if you go to files and versions, what you're looking at here is basically you're looking at Git. You're looking at a repo which has within it the files associated with your model. And as I mentioned recently, you can see that the business here is this file, the safe tensors, and that file is 109 megabytes, which is the size of the adapters, the QLoRA adapters that we're using with R set to 32. When we did the maths, we worked out that would be 109 megabytes worth of weights, and that is all in this file, safe tensors right here. Yeah, there's a few other things that we could look at. Adapter config.json gives information about the adapter that we're using for the LoRa fine-tuning. And you can see, for example, it has the target modules stored in here, and it has our value of R32. It says we're using LoRa training, so it has the base model name, Llama 3.18 billion in there. So that gives you a sense of all of the information that's saved for this model. But the other thing I wanted to point out was this 16 commits over here. So this is showing the commit history, and basically every 5,000 steps, the code that you saw was saving, this was pushing our model to the hub. That was something we configured in the training parameters. So it was being saved every 5,000 steps. And that means that we can load in any of these models and test them. And that's how we can select the one that's performing the best. We've got each of these different checkpoints, and we can do as many of these as we want. And we can use that to come back and recreate that moment when the model was at that point in training. And so you can imagine I could have all of my different training runs all in this as different revisions of this, different versions of this Pricer repository, but then it would get very cluttered. And that's why I separate it out so that each run is its own repo, and then the different batch steps show here as the different history of the commits. I think that's a nice organized way of doing it. So that's how to see the model in the Hugging Face Hub. Presumably we'll see this is the one that's running right now. It's updated 15 minutes ago. So if we go into this, go into files and versions, we'll see that yes, it's already saved a version. We've got to step 5,000. So one version of this, two commits because there was an initial commit, and then step 5,000 has been saved 15 minutes ago. So there's already a model that's running. And if you've been doing this at the same time as me, then you'll be in a similar boat, and you'll be having versions of this model being uploaded to the Hugging Face Hub while I speak. You would be able to test them right away. You don't need to wait for the training to complete. So there we go. We've seen the training underway with the losses showing here that are a bit hard to understand. We've visualized them beautifully in weights and biases, and we've seen the model itself being saved to the hub. And this is the experience of training. And I tell you, I can do this for hours, and I have done this for hours, which is very tragic of me. And in fact, I mentioned, I think right back at the very beginning of this course, that screen you see over there, that actually has weights and biases on it. And the chart that I was just showing you was this chart was the chart that was on there at the very beginning. Right now it's showing this chart here. So I've been watching that during the course of the first few weeks of building this course. And it's been terrific fun. And hopefully you're doing much the same thing, watching the training happening, seeing your model versions being uploaded to the hub. And all that remains is for the run to complete, and then tomorrow for us to come and evaluate the model and see how we have done fine-tuning our own verticalized model. But we'll just wrap up for today. back to the slides. What more is there to say, really? Tomorrow is the day for results, a day that I'm very excited indeed about. But I will mention everything that you can do at this point. Generating text and code with frontier models and their APIs, open source models through Hugging Face's various libraries. Tools, assistants, RAG, it's all part of your skill set. You can follow the 5-step strategy I went through to solve problems, including curating data, building a baseline model, and fine-tuning frontier model with example training sets in those JSON-L, the JSON lines files that we uploaded. And now you can run QLoRA fine-tuning for open source models, including defining and selecting your hyperparameters, and then you can run training and you can monitor training. And a great joy it is too. So tomorrow you will be able to run inference on a QLoRA fine-tuned model, which isn't as simple as it sounds because you can't just load it in. You have to know how to load in the base model and apply these QLoRA weights on top of it. But it's not that difficult, but it is. There are a couple of steps to it. And then, of course, we'll take a moment to look at the results. But most importantly, at that point, you will be able to carry out the end-to-end process from first idea and thought, a definition of the commercial problem, through to having a trained model to build your own proprietary, verticalized LLM to solve a business problem. And I was going to try and put a third bullet in there because I've normally had 3 bullets against the what you'll be able to do tomorrow. But it seems to me like that second bullet is enough of a mic drop that it's like, you don't need a third bullet. That's all you need. That second bullet, it says it all. That's what you're going to be able to do, and it's huge. I'll see you then.